I'm taking a look at that same worksheet. If you're just kind of following along, what I want to do right now is I want to focus on finding inverse functions algebraically. You only need a couple of steps, and it is very much a streamlined process. So I'm just going to jump straight into it. I'm going to take a look at these top few, and then I'm going to give you a hint for the ones down below. But this should get you enough to get you going. So basically, our goal is to come up with the algebraic equation that is going to undo this one right here. I'm looking at the wrong spot. There we go. Let's jump on up to the easier ones. Sorry about that. So here we go. Essentially, what we want to do is this. We want to switch our input and our output. Our x and our y want to switch spots. So that's what we're going to do. We are going to switch our x and our y. Now realize right now that f of x, that whole thing, is your y. The other thing I want you to realize is once we switch them, we need to recognize that we are now dealing with the inverse. So what I'm going to do right now is I'm going to swap my x and my y, and I'm going to make the switch to an inverse. So in other words, I now have x is equal to 2 f inverse of x. All I've done is I've taken my x and my y and I've switched spots, and I've made note that I'm now finding the inverse. And now it's just a matter of getting my f inverse by itself. Well, how do I move this to? I gotta undo the multiplication, so you divide, and so you end up with f inverse of x is equal to x over 2. And logically, that makes sense. If my original equation was times 2, then it would make sense that my undoing equation would be divide by 2. So that pretty much checks out. We can take a look at a slightly more complicated one. I'm going to do the same thing. I'm going to swap my x, my input and my output, my x and my f of x. So I've got x equals 6. I'm going to switch to my inverse, f inverse of 6 minus 5. Well, now I got a few more steps in order to get f inverse by itself. So I'm going to start right here. I'm going to add 5 to both sides. I think I'm going to sneeze again. X plus 5 is equal to 6 f inverse of x. And then I need to undo the times by 6. So let's go ahead and divide by 6. Now be careful, you need to make sure you divide the whole thing by 6. A lot of times I'll see students just want to put the 6 on to the x variable part, but remember you're dividing the entire fraction. So that now gives us f inverse of x is equal to x plus 5 over 6. And that is now an inverse function. Now, let's check this, because I want you to understand what's happening. I'm going to take my original equation. I'm going to use another color. Might as well use some scratch paper too. My original equation right here was f of x equals 6x minus 5. Okay? I'm actually going to change that for a second. So in that original equation, I'm going to pick any number to plug in. It doesn't matter what. Now I'm going to be biased, and I'm going to pick something that's going to come out somewhat nice, just so I make the next part easy. So let's go with 2. I like 2. 2 is nice. So we're going to find f of 2. If I'm going to find f of 2, then that means I need to plug 2 in for x, which means 6 times 2 is 12 minus 5, which is 7. So f of 2 is equal to 7, meaning I now have the ordered pair 2, 7. That's what that original equation is saying. Now, if we did our algebra right, no one said I could speak today. If we did our algebra right, that if I take f inverse of x is equal to x plus 5 over 6, then that inverse equation should undo our original ordered pair. So what I'm going to do is this. I'm not going to plug in 2. I'm going to plug in 7. If I plug in 7, f inverse of 7, I now have 7 plus 5 over 6. 7 plus 5 is 12. 12 over 6 is 2. So in other words, that inverse function now takes in 7 and goes to 2. Algebraically, these two equations undo each other. Whatever you send to the first equation, a number is going to pop out. If you then take that output and you plug it into your inverse equation, it's going to send you back to where you started. That's all inverse functions are doing. They are taking an input, they are taking the output and sending it back to where you started. They undo each other. And then obviously our inverse functions can get a little bit more complicated. So, as one last example, I'll jump down here to part C. Okay? And if I look at C right here, I've got a few more steps going on, but we can figure this out. I'm going to start the same way. I got to swap my input and my output and change it to inverse. So I'm now right here. I am at x is equal to 2 f inverse of x plus 4 all over 5. And what I need to do is go through some algebraic steps in order to isolate this f inverse of x. So in other words, I need to move the 2, the 4, and the 5 all the way over to the other side. But as I do that, I need to make sure I go in the right order. So, first strategy I'm going to give you as a hint. I would love for you to pause this video and try to solve this on your own for a moment. But once you reach a wall or reach a point where you want to check, what we want to do is we want to get rid of our fraction first. So I'm going to multiply both sides by 5. Let's get rid of that fraction top and bottom. So now I'm right here. I am at 5x is equal to 2 f inverse of x plus 4. And now it's very similar to the problem we had just prior. I need to subtract 4 from both sides. So now I've got 5x minus 4 is equal to 2 f inverse of x. And then finally, I'm going to divide both sides by 2, meaning the whole side. So I'm able to write my final answer of f inverse of x is equal to 5x minus 4 all over 2. And if you wanted to, and I would encourage you to, try plugging a point into your first equation, see what you get for the output, and then take that output and plug it into your inverse equation and see that you get back to where you started. The only other thing I'm going to mention right now, we're not going to do a whole problem of this, but I want to go ahead and mention it, is suppose I gave you a quadratic. And with that quadratic, we were asked to find the inverse. Well, here's the dilemma. If I take this quadratic and I swap my input and my output, I swap my x and my f of x, I'm now going to have two of them. There's going to be two f of x's over here. In which case, if I'm trying to get it by itself, that just became essentially impossible. So, this is one of the reasons why we have rewriting in vertex form and completing the square. Because if I were to rewrite that equation in vertex form, x plus 3 squared, that'd be a 9 minus 9, so that'd be a plus 1 on the end. You see how now I only have one x left over? So if you ever find yourself with an equation where you're going to swap because you want to try to find the inverse, but you have two variables, realize, not that you have two variables, but you got two x's. Realize that completing the square and rewriting in vertex form allows us to change the look of the equation, where now all of a sudden I could swap my x and my f of x. I have only one input spot. I have only one output spot. We're not going to be stressing this right at this very moment, but I wanted to hint that for problems down the road.